In this first exercise, we will explore how a bridge can be built in many different ways using different geometric shapes. Through 3D printed prototypes with simple shapes and basic designs, we will compare various types of bridges to understand how the geometry, shape, and arrangement of their elements give rise to varied solutions to the same problem. The goal is to introduce the idea that there is no single correct way to design a bridge, but rather multiple alternatives based on formal and constructive decisions. In this case, we have designed 3 different types of bridges, varying in terms of their geometry and material distribution. Each model seeks to optimize strength with minimum material consumption, which is one of the objectives that the Wenus project aims to instill. The models are printed under the same conditions so that the comparison of designs during testing is fair. Here we can see how the 3D printers do their job and give us the prototypes we have created. Once printing is complete, we compare the different models obtained, their shape, weight, and even the volume of material used for each one. Next, we can see the scales, where the bags that will later be used to load the bridge are weighed. This step allows us to know the weight applied and prepare the test in a controlled manner and see the resistance of the different bridges. Each bridge has been subjected to a load test with the weight we saw earlier. By applying the same load to all models, we observe how different shapes and structural configurations respond differently, demonstrating that there are multiple ways to solve the same construction problem and that all of them can be capable of supporting the weight. This exercise helps us understand that the same problem, such as designing a bridge, can be solved in different ways by using different geometric shapes and structural configurations. If you want to go deeper into the analysis, these models can also be tested to failure to evaluate and compare the behavior of each design. Training ourselves for a more sustainable future. Wenus Project.